In this video, we'll learn how ICMP can be used to test network connectivity and performance. So let's start by just understanding what ICMP is. ICMP stands for Internet Control Message Protocol, and this is not designed to exchange user data. It's not meant to transfer data like emails or web traffic. Instead, ICMP is specifically for error reporting and diagnostics. And the primary ICMP tool that we're going to focus on is going to be ping. Ping uses echo requests and echo replies to test connectivity. And so just think about an echo in real life. So if you yell and your voice bounces off a mountain or something like that, it comes back to you. And if you can hear it, you know you have good echo. Well, a ping is sort of similar to that. It's going to send packets out to a destination, and hopefully it gets an echo back from those destinations, and that's how we verify connectivity. If it's not working, we might get a destination unreachable message. This is a router telling you that it cannot deliver this packet to the required destination. We also might get a time exceeded error. This tells you that a packet's TTL is expired. TTL stands for time to live, and we'll talk more about that in just a moment. So overall, ICMP is vital for understanding whether or not packets can reach their destination, and if they cannot, why have they failed? And ICMP operates at layer 3 of the OSI model. Okay, so let's talk a little bit more about time to live. Time to live defines how many hops a packet can pass through. So basically, if I send an ICMP ping out there, how many routers can it go through before the packet gets dropped? And every router that the packet traverses will decrease the time to live value by 1. So, for example, let's imagine that we send out a packet with a TTL of 128. If that packet goes through 128 routers, it's probably never going to reach its destination. And each router will reduce the TTL by 1. If the TTL value reaches 0, the router then drops the packet. And the purpose of this is to not have packets just endlessly going through networks. If a packet can't get where it needs to go within 128 hops or 256 hops or 64 hops or whatever the value is, that packet is going to get dropped by the router. So here's an example of a ping. And within this ping, you can see the very final value is the TTL. And you can see here the TTL is 118. So that is the value of the TTL when the response was received. And let's just assume that this started at 128. So what that means is that this packet went across 10 routers before we got our response. Okay. So let's try this out. Let's try a few ping commands. And so here I am at the command prompt for Windows, and you can also run these ping commands in Mac or in Linux. And I'm just going to try to ping google.com. And you can see here I'm getting my responses back from Google. So what's happening here is a DNS query is being sent, and my ping is being sent to the IP address value that is returned. By the way, if you ever want to try this and just point to the IP, 8.8.8.8 is the IP address for Google. And so here we can see our response. And you can see the TTL here value is 117. So based upon that, we can determine how many hops this packet went through. You can also see the latency value. And we can see that this packet, this echo response, took 21 milliseconds to come back to us. And we can also see that there is 0% loss. Anything higher than 0% is probably a problem. So if you're seeing a packet loss of 1% or 2%, that's probably an issue. Let's also try this. Let's ping 127.0.0.1. This is the loopback address. So 127.0.0.1 is actually an IP address on every computer in the world. Every computer has this loopback address, and it's basically a local IP address that we can ping. And so why would we ever use this? What's the point of sending a ping to your own computer? Well, you're essentially testing whether or not the TCP/IP stack is working properly on your own machine. So if there's a networking problem with the actual software on your computer, this ping might not actually come back to you. And so this is a good way you can test the network stack on your machine, even if your machine is not connected to the network. All right, so I'm just going to clear my screen here, and now we're going to try another command. We're going to try the traceroute command. So we're going to run a traceroute to google.com. By the way, if you're using Linux or Mac, you actually have to spell out traceroute. So with Windows, it's traceRT. With Linux or Mac, it's traceroute. And so let's try a traceroute to Google. And what it's going to do is it's going to show you each hop along the path. It's going to show you all of the routers that this traffic is going through. And it's also going to show you latency or round trip delay for each one of those hops. You may notice that sometimes you'll see these stars. Some hops are not going to appear. So for example, there might be routers between us and Google that don't want to identify themselves and that want to just ignore these ICMP messages. That's why you're seeing stars for some of these ICMP responses. And there might also be firewalls out there that just block traceroute traffic. So you'll see those stars when a hop doesn't reply. But now we can see all 14 hops between us and google.com. And just one more time, let's ping 8.8.8.8. And let's take one more look at our TTL value. Assuming that we're starting with a TTL of 128, you can see it's only 11 hops here. And if we do a trace route to 8.8.8.8, let's see how many hops it comes back with. And just understand, this is traffic flowing over the internet. It might not always take the exact same path. So a trace route that I run right now might look a little bit different the next time I run it. And so yeah, now we can see the results of our trace route to 8.8.8.8. We can see all of the routers that it went through, and we can see that we are successfully able to reach that destination. Okay, so let's take a moment to review what we've just learned. We learned that ICMP stands for Internet Control Message Protocol, and these are special packets that are used for testing purposes only. They're not used to carry actual traffic. We learned that we can send a ping to get an echo response from a destination, and this is a great way to just verify that we can communicate with a given destination. We also learned that we can use traceroute to show all of the routers between us and the destination that we're trying to reach.